Now on page 173, we're going to do the checkpoints, and then we're going to do some examples that are just a little bit trickier. So what I'll do here is pause, or ask you to pause the video, and then we will show the answers for the checkpoints. You can pick maybe 4 of these 6 to do. That would probably be a pretty good challenge. Go ahead and pause the video now. And here are the answers for the checkpoints. So number 1, we have 249,000. Number 2, it's 0.00056. 3 is 10,001. 4 comes to, well, when you put this back into scientific notation, comes to 6, or 6.0, times 10 to the negative third. 5 comes to 8.2 times 10 to the seventh. That makes sense because it's a big number. And then 6 is a smaller number, so it's going to be a negative exponent here. It's 3.7 times 10 to the negative fourth. And now let's try example 3. So example 3 has got a couple sort of tricky problems. We've got some advantages here. First of all, the properties we know are an advantage, and also we're going to do a little splitting up of the of these problems. So what we're going to do is we're going to split this stuff right here into a piece of the problem. We can do this with multiplication kind of nicely. We're going to split this up, and we're really going to times those. It's all times anyway, so it's okay. What we're going to do is let's start by taking our calculator out, and we're going to do 5.4 divided by 7.2. Now that comes to 0.75. So we're going to write a 0.75 in there. And then right here, go back to a property we used earlier in 8.4, and it says that when you have the same base, you can, and we're going to divide these, we're going to subtract the exponent. So it's negative 2 minus negative 6, which of course is negative 2 plus 6, which is 4. Now, this one right here, what I'm going to ask you to do is go off to the side here and really evaluate what is 0.75 times 10 to the fourth. Well, what that means is we're going to take the decimal, we're going to move it 1, 2, 3, 4 to the right, and really what this is 7,500. Now, 7,500 we have to actually put into real scientific notation, because this original one, this up here, where it said 0.75 times 10 to the fourth, that was not scientific notation. So what we're going to do is we're going to find where our decimal point is, and it's right here. We're going to go 1, 2, 3, and drop it right there, because then it's between 1 and 10. So it's 7.5. And what has to happen here, when you have 7.5, to make it bigger here, we're going to move it actually 3 spots to the right. And that's really what this number is. It's another way to write this in more correct form. Okay, now let's move it down to example B. Example B, when we cube a number, in fact, something in parentheses that's being times, when we cube it, we're going to apply that cube here, and we're going to apply the cube here. So the first cube is 3.0 to the third power, which is 3 to the third power. And then this thing right here, we actually, if you remember this, we have to multiply those two. So it's going to come to base of 10 times negative 4, or I'm sorry, to the negative 4 times 3, which is negative 12 power. Okay? Now let's make this into 27, because that's what it is. And this is still 10 to the negative 12th power. Now we'll do a little trick here. We're going to split this 27 in, or we're actually going to write this into scientific notation. We'll leave this thing alone real quick. So this is going to be a negative 12 right here. Now 2.7 times 10 to the what power, I'm sorry, 27 times is really 2.7, because this is scientific notation, to 10 to the first power, right? Because you'd be moving it 1 spot over to make it 27. So now let's put this stuff together. Let's leave the 2.7 like it is. Remember, with multiplication, you can kind of play around with this in any order you want. We can actually now put these together. What's we got the same base 10. Now what's 1 plus negative 12, or 1 minus 12? It's negative 11. So the final answer is 2.7 times 10 to the negative 11.